The naive picture about science is we're constantly trying to falsify our old theories, and once the model has been proven wrong, it's immediately discarded. Now, this is not entirely wrong, but it is inaccurate. The truth is that often quoted sentence, all of our theories are wrong. It's just that some of them are useful. And let's be clear, I don't just say that to be cute or witty or anything. This is literally the way actual science is done. Because it's not just about being right or wrong, it's more like infinite sieves. The inevitability of being wrong. Falsifiability is central for science because you must always be able to prove something wrong. And being wrong is simple enough because wrong is wrong, right? The thing is this. Very often when you talk about two categories, if you look close enough, those are just the two endpoints of a spectrum. And that also applies here. Being wrong is actually a spectrum. We can picture scientific testing as just a series of filters or sieves. So a model is given a first test, and if it fails, but if it passes, it deserves a closer look. So it gets a second sieve. And so on, and so on, and so on. The more tests a model passes successfully, the more interesting the model becomes, but also the harder it becomes to pass any more tests, until eventually, inevitably, the model fails. But why inevitably? Models, by their very nature of being models, are just simplifications and generalizations. If they weren't, they wouldn't be useful models in the first place. So unless reality is very simple, which it isn't, models are always wrong. All right, if all models are wrong then, how can any of that be useful? In essence, we just look where a model gives accurate predictions and where it fails, where it is wrong. And if this domain where the model is correct is small or uninteresting, then nobody will give a shit. But if it gives accurate predictions for many cases or for important cases, it is a useful model. Let's look at two very simple examples to appreciate this difference. All swans are white and all birds are white. How wrong models can be worthless. If you've ever been outside and you've seen birds, you know that all birds are white is a pretty useless model. It holds true only in very specific times and very specific places. And you have to ignore probably 99% of birds in the world. This model is wrong in a useless way. It will not even pass the first sieve. For example, homeopathy. All of its basic premises are wrong. The law of similars, that like cures like, wrong. The idea of homeopathic dilutions, that preparations become ever more potent the more you dilute them. Wrong. The idea of water memory, that water retains the essential properties of something it was in contact with. Wrong. The idea of a spirit-like healing force in a solution that you can awaken by shaking it. Wrong. Bullshit. We know today that the complete mechanistic model behind how homeopathy is supposed to work is completely wrong. Now, to cut homeopathy some slack. At the time it was invented, around 1800, it probably wasn't much worse than what was then called medicine. Medicine back then was far from being scientific, and some of its practices did more harm than good to the human body. So maybe homeopathy was not the worst idea at that time. But we don't live in that time anymore. And today we should treat homeopathy the same way we treat leeching or bloodletting. In homeopathy, all birds are white. How wrong models can be useful. All swans are white. Well, historically, all the swans people ever knew had been white. It turned out, however, that there are black swans in Australia, so this simple theory had been disproven. This example is often cited to show that just because you only know things to be in one particular way doesn't mean that all the other things are the same way. It's what philosophers call the problem of induction. Knowing a few things and generalizing to all things. So this example is really often just a philosophical version of gotcha. But really, I think that misses the point. That misses the most important point. Obviously, it is wrong in a trivial sense, but we already said all models are wrong, so it shouldn't surprise us. Because despite being wrong, all swans are white is actually a great model for 95% of the world and the vast majority of swans on the planet. What we really learned actually is just this model does not apply in Australia. Newtonian mechanics, including Newtonian gravity, were published in the 1780s, and they explained how gravity works and how motion can be understood and, more importantly, how it can be calculated. Both models were used with great success for more than 200 years until they were disproven in 1905 and 1915 and again in the 1920s. That was more than 100 years ago, and despite that, Newtonian mechanics is still being used to this day. And not just because it's being taught to kids in high school, but any structure, any mechanical structure in any machine today is still being engineered based on Newtonian mechanics. Bridges, buildings, cars, planes, space rockets, everything is built using this wrong model. We even flew to the moon using the wrong model of gravity, and we will probably do that again with Mars. And the reason for this is simple. Newtonian mechanics has been proven wrong for not just one, but several domains. It does work in one domain, and this just happens to be most of our everyday world. See, when I'm designing a car, for example, I don't have to care for quantum mechanical corrections, which are on the order of the scale of atoms, when my manufacturing precision is millimeters. Neither do I have to care for relativistic effects when the car is going 300 million kilometers an hour, when it can barely do 300. And that's why in Newtonian mechanics, all swans are white. Conclusion: wrong, but still useful. So, what can we take away from this? First, with scientific models, it's not so much a question of being right or wrong, it's more a question of how wrong something is. For this we used our picture of the chain of thieves. Also, models as such are always simplifications, so they must always be wrong at some point. So it's really all about mapping out where are models right, where are they wrong, and if they apply to an interesting domain, they are useful, even though they are wrong. And that is exactly what we mean when we say all of our theories are wrong. It's just that some of them are also useful.